All right. So I forgot to record notes yesterday. So we are doing a whole bunch of examples on verifying identities, but I've got some helpful tips and tricks before we get started too far. The first thing is only work with one side of the equation. And the biggest thing I always tell kids is you only want to work with the nastiest side of the equation the vast majority of the time. It's going to be like if you look at this first example, it is easier for me to turn the monstrosity that I see over here on the left into a 1 than it is for me to change that 1 into that nastiness. Second step is look for any factoring, expanding, adding, or subtracting fractions and common denominators. Look for identities, specifically your Pythagorean identities. That is sine squared plus cosine squared equals 1. Fourth one is try changing stuff to sines and cosines. So anytime you see tangent or cotangent, you might want to change those. Keep the end in mind. So if you know you need to get to a certain answer, make sure you're paying attention to what that answer needs to have so you can pull specific things as you go through. And the last step is try something. Even if it doesn't work, you've at least figured out one way where it's not going to work. So we've got our first example here. And while it looks beautiful, I'll probably just handwrite them in for the rest of it. And I always do them like 2-column. So I go through and write that. So the first thing I'm going to start with is I'm going to try simplifying my numerator. So I've got sine squared plus cosine squared. And if you look on your reference sheet, that is a Pythagorean identity. And I know that that equals 1. All right, then I'm going to switch up and look at the bottom where I've got cosine squared times secant squared. Well, if you look at secant squared, I know that that is 1 over cosine squared. And cosine squared over cosine squared is also 1. So this comes from reciprocal identities. And then a whole bunch of simplifying. So my final step is literally just putting everything back together. So I have 1 divided by 1, which is 1. And once you are done with that final step, you write QED, which is Latin for it has been demonstrated, which is fancy vernacular for suck it, I win. Most of the proofs when you're first starting will only be a couple lines long, but eventually they start getting up into more complicated, longer problems. So let's do another one. I've got secant squared of x minus 1, sine squared of x minus 1 equals negative sine squared of x. One of the things kids noticed yesterday is I tend to drop the x's or the thetas as I'm going through and doing stuff. Technically, that is bad math juju, and we don't do that, but I'm lazy and it's May, so why not? So for secant squared of x, I'm going to look at one of my Pythagorean identities again. I know that 1 equals, or nope, it is 1 plus tangent squared equals secant squared. So you can choose to either replace the secant squared, or you could subtract this 1 over to the other side and just get, okay, well, tangent squared equals secant squared minus 1. And I can replace that entire set of parentheses with tangent squared. Then if I look at this one right here, again, sine squared plus cosine squared equals 1. So if I swap my cosine squared and my 1, I am left with, hang on, I got to move some of this. You crap in red, come here. It won't let me select all of it. Stupid. Anyway, I've got sine squared minus 1 equals cosine squared. Sorry, I ran out of room. So if sine squared minus 1 equals cosine squared, that set of parentheses just becomes cosine squared. Now, what I would write over on the side for my reasons would be, these are a bunch of Pythagorean identities. And I just did some basic algebra to get them in the format that I need them to be. Now, I've got tangent squared. I'm going to change that into sine squared over cosine squared times cosine squared. I want it green, you stupid thing. Keep my colors consistent. Cosine squared over 1. So you'll notice, and reasoning wise would be, this is a quotient identity. Quotient identities and reciprocal identities are in the same section on your purple sheet. Literally, it's just whenever you go from sine squared over cosine squared to tangent and back again, that's what it does. Now back to this, if I notice, those cancel out. Oops, this should have been negative. I done goofed. Now we're good. So those cancel out, and I am just left with negative sine squared of x. So what I would write over here is this was just simplifying. And because I have gotten to the negative sine squared of x, which is what they wanted, I can write QED, and I'm done. Next one, I've got 1 minus sine of theta over cosine of theta equals secant of theta minus tangent of theta. Now, this one could go both ways. You could pick the right side, you could pick the left side, because there's really not one easier way than the other. But if I'm doing it, I'm going to start on the left. And the reason I'm going to start on the left is because I can actually split this into two separate fractions. So it'll be 1 over cosine minus sine over cosine. And my reasoning would just be split the fraction. Now, if you notice, 1 over cosine, this becomes secant. Sine over cosine is tangent. That is literally all I wanted. I am technically done, but reasoning-wise would be reciprocal and quotient identities. And literally for these notes, all I'm doing is I'm doing a crap ton of proofs so you guys can just see a whole bunch of different ways to solve stuff. So I've got cosine of x times tangent of x times sine of x times cotangent of x equals, oh no, and this one equals sine of x plus cosine squared of x. So again, a couple of different ways we can solve this. And the one I showed in class was just dealing within the parentheses first, but we can actually distribute that cosine of x in. So I've got cosine of x, and you'll remember I get rid of all the x's because it's already alphabet soup. And what I tend to do with this is I will also change my tangent and my cotangents into being sines and cosines. So tangent is sine over cosine, then plus sine times my distributed cosine times, for cotangent, it's cosine over sine. Now, the thing I tend to point out to students is those cancel and these cancel. So I'm left with sine of x, cool, what I wanted, and then plus cosine squared of x. And reasoning wise, I would write distributive property. And then I used a whole bunch of quotient identities. And then I simplified. QED. You have to put QED at the end, and I know that part sucks for kids because they're like, well, why? It's how you symbolize to whoever's grading it that you have finished the problem. So don't just write QED willy-nilly. Actually write it when you're done. And then I've got, for this one, 1 minus tangent of x quantity squared equals secant squared of x minus 2 tangent of x. So I'm going to start with the left-hand side, and I'm actually going to FOIL this out. And I'm not going to write it because obviously I'm running out of some paper. So I've got 1 minus 2 tangent plus tangent squared, and that is FOIL. Once you've got that, my recommendation to kids is to rewrite it, because if you notice the 2 tangent of x, I want that. I need that in my final answer. So I'm just going to move this over here, and that is just reordering. And then if you look at your Pythagorean identities, this one's back. This is actually secant squared minus 2 tangent. And that is the end of that proof. And that was a Pythagorean identity. So that was Monday's notes. And then I did a couple of problems in class today, which is Tuesday. So we could make sure we had kind of seen some other solving methods. So the one I did in class today was 1 minus sign. And the symbol I used in class was beta. Beta is literally a placeholder. I don't care if it's X. I don't care if it's theta. Betas are just fancy bees with tails. And this equals secant of beta minus tangent of beta quantity squared. So this one, my solving method is actually going to be using conjugates. So we did conjugates back in unit 2. So I've got 1 minus sign over 1 plus sign. And the conjugate that I need is the opposite sign for the denominator. So it's going to be 1 minus sign times 1 minus sign. So this is multiply by conjugate. When I go to do this, I am left with 1 minus sign quantity squared on top. And then on the bottom, I get 1 minus sign squared. Now, 1 minus sign squared, and all I did was factor, no, not factor, FOIL. And I would actually FOIL out the numerator as well. So that's going to be 1 minus 2 sine plus sine squared all over 1 minus sine squared. FOIL again. When I look at this, I'm going to pay attention to a couple of different things. The first one I want to pay attention to is my denominator. So remember, you've got those Pythagorean identities where sine squared plus cosine squared equals 1. And if you move that sine squared over, you'll notice that cosine squared equals 1 minus sine squared. So I'm actually going to take my denominator and replace it completely with a cosine squared. And I'm going to do one additional step, and I'm just going to reorder some stuff, and I'm doing that on purpose. So Pythagorean identity. All right. So you can actually split this into 3 separate fractions, which is one method of doing it. The one thing I would point out is you've got 1 over cosine squared plus sine squared over cosine squared minus 2 sine over cosine squared. So split the fraction. And remember, you can simplify a lot of these down. So 1 over cosine squared becomes secant squared plus this is now tangent squared. And this becomes, this one looks ugly, and I'm going to split it so you can really see it. Minus 2. And then it's sine over cosine times 1 over cosine. Now, you'll notice that the sine over cosine looks very similar to this. And, well, that one was squared, so it became tangent squared. So secant squared plus tangent squared minus 2 tangent times secant. These were reciprocal and quotient identities. And I know this looks disgusting, but it really is factorable. So if it was u for secant and v for tangent, I would essentially have u squared minus 2uv plus v squared, and that would factor into u minus v quantity squared. And then we can replace that with secant and tangent, and we are done. But I ran out of paper, so I'm just going to write QED here. All right. I'm trying to think if we want to do another. Well, I've got a whole nother page. Why not? So for the next one I'm going to look at, I'm going to do cosecant of x minus sine of x equals cosine of x times cotangent of x. And again, you'll notice a lot of these, I spend quite a bit of time really just focusing on the left side. I have no idea why we put the more complicated stuff on the left, but that's how it always seems to be working. So the first thing I want to do on this one is I want to change cosecant to be 1 over sine minus sine. And that is just a reciprocal identity. Now, the thing on this one is I can't actually add or subtract these 2 fractions until I get a common denominator. So for me to get a common denominator, I need to multiply this side by sine over sine. So I've got 1 over sine minus sine squared over sine. And that was common denominator. Combine these. And the big thing I want to point out is, remember that Pythagorean identity again. This becomes a cosine squared. So now I've got cosine times cosine all over sine. So remember, my answer is cosine times cotangent. Well, I want one of these cosines to stay by themselves. But cosine over sine, this part is cotangent. So what would I call this? Split numerator and simplify. I have gotten to where I want to be, so I'm going to write in QED. and I am set. I'll do this one because I know one similar to this comes up on the homework and a lot of kids were freaking out about it. So cosine to the fourth of x minus sine to the fourth of x equals cosine squared of x minus sine squared of x. Now, I would use a u sub on this one, and I'm going to set u to equal cosine squared, and I'm going to do a v substitution for sine squared. Now, I did this for a reason. This will end up becoming u squared minus v squared. Remember, if it's of this form, you can write it as u plus v times u minus v. So I've got cosine squared plus sine squared in the parentheses on the left, and then in the parentheses on the right, I've got cosine squared minus sine squared. So u sub, factor, undo your u sub, and check this out. That's 1. So I am actually done. And the biggest thing with proofs is you just have to continue to practice them. I always recommend to kids that if they get stuck, they try to pull my answer key and find what my first step was, because you can reuse that to help get you started until you can see some more of these strategies and whatnot. So I've got a couple more, but let's be honest, you guys are probably zoinked, tired. So I am, if I could figure out how to pause it, done.